Question number 24. A and B part we have dealt with XY coordinates, that is Cartesian coordinate arrangement. Cartesian coordinate arrangement is you have x-axis and y-axis. Suppose you move distance 3 along x-axis. You start from origin, you move 3 units along x-axis, 1, 2, 3, then 3 units along y-axis. So you reach a point P which is 3 along x-axis and 3 along y-axis. Coordinate of point P is xy, it is 3 and 3. This is one way. You are at O and you want to reach at P. It is possible that there is a road which moves straight, then you take a left turn, then you move from position O to position P. This is one way of doing it. So this arrangement is known as Cartesian coordinate arrangement. If you have to move by air from O to P, what is the distance covered? Yes. One way is that you move 3 units along this, 3 units along this. This is one way of doing it. Second is that you move by air from O to P directly. This distance comes out to what? 3 root 2. What about this angle? Yes. This is 3, this is also 3, this side, this angle is 90 degree, this angle is 45 degree, this is also 45. So when you move by air, the pilot gets instruction that you move 3 root 2 making some 45 degree with the north. This arrangement where you specify two aspects, one is R, second is theta, is termed as polar coordinates, where you specify R and theta. We have dealt with yesterday in the previous part E is equal to minus change in V by change in X along, yes, small increment along x-axis direction, x-axis I, minus dV by dy. This small increase along y, this is direction along yj, minus dV by dz along k. Small increase along z and direction along k. 2 minutes to write the same. This is your Cartesian coordinate system. Today we will take a polar. It is 24C to be used in question number 26. Now we want to write a relationship between E and V for this arrangement, polar coordinate system. So this position is origin O, this distance is R, angle is theta. This is one part which we have already discussed. This is polar coordinate arrangement. In polar coordinate arrangement, E is equal to minus dv. Yes, this was dx increase along a x-axis. Direction was I. This direction is termed as radial. Unit vector along r. If you move in this direction, it is termed as radial. So small increase in this direction is how much? dr. So it is equal to what? E is equal to minus dv by dr. Direction is unit vector along r. Write it. And the direction perpendicular to this direction, this one, is termed as angular. How? If you move it from theta to theta plus d theta, that is this is r, this small angle is d theta. What about this magnitude? Yes, anyone? This distance is r, yes, circle. This is d theta, this is r. What about this one? R d theta. So this distance is how much? This distance is r d theta. And you have moved in this direction. Increase is in this direction. This direction is termed as angular. Unit vector in angular direction. So it is equal to minus dv by dr, again minus dv by something. Direction is theta. What about, what are the units for this? Distance meter, distance meter, distance meters. This is also distance. So here it is not d theta. It is r d theta. This is the arrangement for polar coordinates. So you have two directions. One is radial, perpendicular to radial. This direction is known as angular. 1 minute to write. 1 minute to write.